Hi, my name is David Chu. I am a research fellow in the School of Mathematics at KIAS since January 2025. My main research interests are geometric group theory and hyperbolic geometry. So I did my PhD in France, where I had two supervisors, Professor Bruno Duchesne from University Paris-Saclay and Professor Kieson Lee from Seoul National University. While I was looking for a postdoc position, Kieson told me about this research fellow position at KIAS and encouraged me to apply, so I followed his advice. I work mainly on the infinite-dimensional hyperbolic space, which is the infinite-dimensional analog of the classical hyperbolic spaces. In particular, I am interested in groups acting on this space by isometries. One challenging problem I would like to solve is to find a good way to define a notion of lattice in infinite dimension. The notion of lattice is very important in finite dimension, but it is not well defined in the infinite dimensional setting, and there are several ways to generalize it to this context. So I would like to know how we should define these lattices in order to be able to build the theory of infinite dimensional hyperbolic manifolds as in the classical finite dimensional case. For me, mathematics is about understanding how things work. And to do so, mathematicians like to build simple abstract models that they can study in depth. All the properties that they can derive from this then apply to all situations and instances that fit into the model. Also, mathematics is a kind of language. It provides some structures that let us follow and communicate ideas. And beyond that, doing mathematics often feels like playing a game to me, where we ask fun questions and try to figure out some elegant solutions to them. Let me try to illustrate the idea of geometric group theory. When we want to understand a geometric object, we often look at its symmetries and how we can move this object while keeping some things unchanged. For example, imagine I draw a shape on this piece of paper. So I'm drawing just some shape here. And if I tell you that this shape looks exactly the same no matter how I rotate the paper, then what shape could this be? Well, this is a circle. This is the idea of geometric group theory, looking at how we can move the object by preserving some properties and then deducing some things about this object. I think I was always attracted by mathematics in the first place because I enjoy logic puzzles and riddles. But what really motivated me to do mathematics as a job was some opportunity I had in high school, where I had the chance to take part in some kind of internship in a math institute organized by a science outreach association. At this age, most people don't really know what they want to do in the future, and at that time, I had no idea what research in mathematics could be. I could only imagine something vague like finding new numbers or new shapes. Well, the goal of the internship was to show us what the life of a math researcher looks like and to teach us some mathematics that were not in the high school curriculum. I discovered differential equations back then through applications to biology and to the dynamics of populations. There were also some kind of mini conference where all participants could give a short presentation about what they learned during their internships. Overall, I really enjoyed this experience, and that's what motivated me to continue doing mathematics, even though I didn't continue in the direction of differential equations. My childhood dream was to become a doctor. I wanted to study medicine, and I guess I fulfilled the doctor part of my childhood dream. So outside research, I enjoy sports. In particular, I like bouldering and playing table tennis. I don't listen that much to music, but I enjoy playing music. I used to play the accordion, and I also played a bit of violin in the university symphonic orchestra when I was a graduate student. Outside research, I like to do sports during the weekends. I also enjoy going to restaurants and trying new dishes. And since I am in Korea now, I also spend some time every week learning the language little by little. Well, I think that KIAS is a great and very active research institute There are many events happening here, like workshops or conferences. I have had the opportunity to meet a lot of people. Well, I think KIAS provides a very good work environment for researchers and takes very good care of them. The administrative staff is wonderful. They are always very helpful and welcoming. I also really enjoy the daily tea breaks, where KIAS provides snacks and fruits to everyone. I think we are really spoiled here. My interactions at KIAS have helped me broaden my research horizons. I discovered topics that I didn't know much about before. For example, I had the opportunity to learn about semigroup theory here, and I even started some project on this topic with another research fellow here.